Now, we'd like to do something a little bit more complicated than printing the same hello world 4 times. In other words, we'd like each thread to do something slightly different depending on which thread is executing. We're going to save this into hello world3.c. We are going to say, okay, let's extract the maximum number of threads that are available. In other words, the number of threads that we set with export omp num threads equal to 4. And we'll store that into a variable called max threads. And there's an inquiry routine that's part of OpenMP that says get the maximum number of threads. Okay, so now the main thread knows what the maximum number of threads is. And when we reach the parallel section, if we print that, each of the threads will have that same variable because it was created outside of the parallel section. All right, so if we go over here and we say gcc-o hello world 3.x hello world 3.c, and remember we had to link in the OpenMP library. And then for good measure, let's export omp num threads equal to 4 just to be safe. And then let's execute hello world 3.x. And lo and behold, we now get 4 copies where it also prints out what the maximum number of threads is. That's still not particularly interesting. So let's go back over here. And let's now make a little bit more complex parallel section, which means that we're going to put some curly brackets in. And now within that parallel section, let's local to each thread declare a new variable called, let's call it number of threads. And that is set equal to what is returned by a routine called omp get num threads. Okay, and that tells the thread how many threads are part of this parallel section, how many threads execute this parallel section in parallel, because it doesn't actually need to be the maximum number of threads, the total number of threads available. And also we're going to set the TID, the thread ID, equal to omp get thread number. And that tells each thread what its index is among what they call the team of threads that's executing this parallel section. And that ID will be 0, 1, 2, or 3 in our case because we set the maximum number of threads equal to 4. And what we can do now is say printf from, and then the index of the thread of, and that's for good measure, print out the number of threads in the parallel section and also the maximum number of threads. So we print out TID and end threads, and we save this still in hello world.c. And then if we go over here, we can compile it and execute it. And now we notice that we get a different message that's printed by each of the threads. And what's also important to notice here is that the order in which they print is not necessarily 0, 1, 2, 3, because these threads are running asynchronously and you're not quite sure which one gets to the print statement first. All right, so now you have seen a very simple program that executes differently depending on which thread it is, so that collectively they do something a little bit more complex.